Today's session is about application of integration in business and economics. In this session, we will focus on computation of revenue, cost function, demand, function and profit function from the given function, determination of consumer and producer surplus from the function given in both monopoly and pure competition market. First, let's understand some terms and formulas used here. Total cost TC is equal to the sum of cost of all inputs used to produce goods and services. TC is equal to TFC plus TVC. TVC total variable cost, that is the cost of inputs that changes with outputs. TFC total fixed cost, the cost of inputs that are independent of outputs. Marginal cost M.C, change in total cost that results from a change in output. MC is equal to delta TC by delta Q is equal to D of TC by DQ. Average cost AC, total cost per output, AC is equal to TC by Q. Calculating marginal functions. MR is equal to D of TR by DQ. MC is equal to D of TC by DQ. Given MR and MC, use integration to find TR and TC. These are the formulas. Basic integration formulas used in this session. Example 1. Find total cost. If marginal cost MC is given by 40 where X denotes output produced. Also find total cost when X is equal to 0 and X is equal to 100. Solution. MC is equal to this is equal to 40 by root. TC is integration of MC dx. Integrating 40 by root X. Root X can be written as X power minus half. Integrating, we use this formula, we get this. 80 times to the power 1 by 2 plus C. When X is equal to 0, TC is equal to C. When X is equal to 100, TC is equal to 800 plus C. Example 2, given that MC is 2 plus 60Q minus 5Q square where Q denotes the units of commodity. Find total cost and average cost function if fixed cost is 65. Solution. TC is this, integrating MC, we get this, is equal to 2Q plus 30Q square minus 5Q cube by 3 plus C. When Q is equal to 0, TC is equal to FC is equal to 65. Therefore, TC is equal to 65 is equal to 2 times 0 plus 30 times 0 minus 5 times 0 by 3 plus C. C is equal to 65. Put C is equal to 65 in above equation for TC, we get this. AC is equal to TC by Q. Substituting the values we get this. Example 3. Given that MR marginal revenue is 12 minus 8x plus x square. Find revenue and demand function. X denotes the units of output sold. Solution. We know that MR is differentiation of TR and integrating MR, we get TR. Here MR this integrating we get TR, this C is integration constant. When X is equal to 0, TR is equal to 0, therefore, substituting, we get C is equal to 0, TR is equal to this plus 0, thus, total revenue or revenue function is this. Demand function P is equal to TR by X. Substituting and simplifying, we get P is equal to 6 minus X whole square by 3. Where P denotes price per unit. Example 4. MR marginal revenue and MC marginal cost of a firm is given by MR is equal to 12 and MC is equal to 4 plus 0.08x. Find the level of output for maximum profit. Compute maximum profit, given that the total cost at 0 output is 0. Solution. For maximum profit, MC is equal to MR. Given MC and MR, equating we get 100. Since MR is equal to 12 constant, therefore, the market relates to perfect completion. Therefore, market price P is equal to MR is equal to 12. Total revenue, total sale proceeds is equal to P times X is equal to 12X. Total cost TC is equal to integration of MC. MC is this, integrating, we get TC is equal to 4x plus 0.04x square. When TC is equal to 0, X is equal to 0, therefore, substituting values we get C is equal to 0 and hence TC is equal to 4x plus 0.04x square. Total profit pi is equal to TR minus TC is equal to 12x minus 4x plus 0.04x square is equal to 8x minus 0.04x square. Substituting x is equal to 100, total profit is equal to 400.
Example 5. The marginal cost function is MC is equal to 16x minus 1591 and the marginal revenue MR is equal to 9. Find the output at which the profit is maximum when the fixed cost is 1,800 rupees. Also find the maximum profit. Solution. MC is equal to 16x minus 1591. TC is equal to integration of MC. MC is 16x minus 1591, integrating we get this. When output x is equal to 0, C is equal to fixed cost is equal to 1800. Substituting the values, 1800 is equal to 8 times 0 square minus 1591 times 0 plus k. K is equal to 1800, substituting the value of k. TC is equal to 8x square minus 1591x plus 1800. Now, MR is equal to 9 is given. We know TR total revenue is integration of MR marginal revenue. Integrating we get this. Since revenue is nil when there is no output, we have 0 is equal to 9 times 0 plus K1. K1 is equal to 0. Therefore TR is equal to 9x. Now profit. Pi of x is equal to TR minus C. Substituting the value of TC and C, we get this. Simplifying, this is obtained. Differentiating, we get is equal to minus 16x plus 1600. For maximum profit, differentiation of pi is equal to 0, so minus 16x plus 1600 is equal to 0. X is equal to 100. Differentiating again. Double dash, that is second order differentiation of x is equal to minus 16. For x is equal to 100. Double dash of 100 is equal to minus 16 less than 0. Profit is maximum at x is equal to 100. Now, maximum profit is equal to of 100. Substituting this value in minus 8x square plus 1600x minus 1800 and simplifying, we get 78,200 rupees. Consumer surplus and producer surplus. Consumer surplus, CAS, refers to the difference between what a consumer is willing to pay and what they paid for a product. For example, let's say that you bought an airline ticket for a flight to Taj Mahal during school vacation week for 1,000 rupees, but you were expecting and willing to pay 3,000 for one ticket. The 2,000 rupees represents your consumer surplus. The producer surplus is the difference between the market price and the lowest price a producer is willing to accept to produce a good. Example, a company sells 30 items for 10 rupees each, and it costs them 3 rupees in marginal costs to produce each item. Producer surplus is equal to the revenue, 10 rupees x 30, minus the marginal costs, 3 rupees x 20, which is equal to a producer surplus of 140 rupees. Example 1. If the demand curve is P is equal to 20 minus 2x where P and X are respectively the price of the amount demanded of a commodity, find the consumer's surplus when P is equal to 6 and P is equal to 10. Solution. When P is equal to PO is equal to 6, we have P is equal to 20 minus 2x, 6 is equal to 20 minus 2x, x is equal to 7. When P is equal to PO is equal to 10, we have P is equal to 20 minus 2x. 10 is equal to 20 minus 2x. X is equal to 5. Consumer surplus CAS is equal to integration of demand function minus price times quantity demanded. Integrating demand function 20 minus 2x from 0 to 7 minus 6 times 7, we get this. Simplifying, we get 49. Similarly, P naught is integration of 20 minus to x from 0 to 5 minus 10 times 5. We get this. Simplifying, we get 25. Example 2. The demand law for a commodity is P is equal to 20 minus to D minus D2. Find the consumer surplus when demand is 3. Solution. Here P is equal to F, D is equal to 20 minus to D minus D square. When the demand D is equal to D naught is equal to 3, the price P is equal to P naught is equal to 20 minus 2 times 3 minus 3 square is equal to 5. Integrating the demand function 20 minus to D minus D square from 0 to 3 and subtracting 5 times 3, we get this. Simplifying, we get 27. Example 3. Let P be the price of rice, Q the quantity of rice, and is the amount of fertilizer in the production. Using data for India for 1949 to 1964, Taina and Patel, we find demand function for rice as P is equal to 0.964 minus 6.773 Q and for the supply function 0.63 plus 0.036 S. A. Find the equilibrium price and quantity in the rice market if S is equal to 0.5. A. Find the consumer's surplus. Solution. Demand function for rice P is equal to 0.964 minus 6.773 Q, 1. Supply function Q is equal to 0.63 plus 0.036 S, 2. We known, for equilibrium, quantity demand is equal to quantity supplied. Substituting the value of Q of equation 2 in equation 1. P is equal to 0.964 minus 6.773 times 0.63 plus 0.036 S. Substituting the value of S is equal to 0.5. P is equal to 0.964 minus 6.773 times 0.63 plus 0.036 x 0.5. P is equal to 0.415, let this be P naught. Substituting the value of S is equal to 0.5 in A2, Q is equal to 0.63 plus 0.036 x 0.5, Q is equal to 0.081, let this be Q naught. Thus P naught is equal to 0.415 and Q naught is equal to 0.081 are equilibrium price and quantity exchange. B. Consumer surplus CAs is integrating demand function 0.964 minus 6.773 from 0 to 0.081 minus P naught times Q naught, which is this, simplifying 0.0 to 2. Example 4. The demand and supply function under perfect competition are y is equal to 16 minus x square and y is equal to 2x square plus 4 respectively. Find the market price, consumer's surplus and producer's surplus. X denotes quantity demand or supplied, y denotes price. Solution. Demand function y is equal to 16, x to equation 1. Supply function y is equal to 2 times 2 plus 4 equation. Subtracting 1 from 2. 3x square minus 12 is equal to 0. X is equal to plus or minus 2. Minus 2 is discarded. Now, x is equal to 2 is equal to x naught. Sub x is equal to 2 in equation 1. Y is equal to 16 minus x square. Y is equal to 12 is equal to y naught. Thus, when the quantity demanded or supplied is 2 units, the price is 12 units. B. Consumer surplus CAs is integration of demand function 16 minus x square minus P naught times Q naught, that is 2 times 12, we get this, simplifying, we get 16 thirds. C. Producer surplus PS is equal to P naught minus X naught minus integration of supply function from 0 to 2. We get this, simplifying we get 32 by 3.